Okay, so in every application it is recommended to have except global exception handling, so that when there is any exception happening, you as the developer or the owner of the application know that some unhandled exceptions occurred and you can take action on it, especially if those are critical errors that are um, making the users unable to use your application. So the first thing we do is we are going to take advantage of the shared project to make this ready for have a custom login implemented to be accessible from both the client and the server. Now we are going to do this just for demo purposes, but um, the way we are going to do it in the client side is not the best way to do it, because the way we are going to do it, we are going to have our settings in the client side project. So basically our URL and the private key for the Azure storage, it's going to be in the client project. This is a way to implement it, so you can check one of the ways to implement a custom logger provider, but it is not recommended for the client-side project, just for the server project. But we are going to do it so you get some idea of how you could implement it. Okay, so basically what we need to do is in the shared project have a custom login folder, and then we are going to implement a custom logger provider class. Now before we continue, please remember to subscribe to the channel, hit the notification bell so you are notified when there are no new videos uploaded. Share the videos, like them, write in the comments things you will like to learn about .NET Core, Azure, and Unity3d. Let's continue. So here you see that we have a class named custom logger provider that implements a logger provider, and then we have to write the methods that are defined in this interface. Now the iLogger provider actually comes from the Microsoft extensions login NuGet package, so you need to add that NuGet package. This is the file which is going to have the code to store the data in an Azure storage file table. So you also need to add the Microsoft.azure.cosmos.table package. So basically what we will have is a dictionary of file loggers, the string file logger, where the key is going to be the category, and the second is going to be the logger instance, and we are going to have private variable, which is the custom logger configuration, which we also have defined in this file. Then we implement the we save we receive the custom logger configuration as a parameter. We save it into a private variable. Then in the create logger method that comes from the interface, we basically create a new instance of the logger if there is not one in the dictionary, and if there is one in the dictionary, we just retrieve it by using the category name as a key. We are not implementing the dispose in this situation. Now you see here we have the custom logger configuration, Azure Storage Key, Azure Storage Account Name, and Azure Storage URL. So you will see that in my client side, the app settings already have the custom logger configuration and the Azure Storage Key, the account name and the Azure Storage elements or properties, which are the ones that match the properties in the class. Okay, so this app settings.json having this configuration is what I said. It is not the recommended way, or is not one of the best ways to solve this using WebAssembly. One possible way to avoid having your secrets in the WebAssembly portion is basically just create a end, an endpoint in your server side, in your server project. You create a network controller, something like that, and when there is an error happening in your WebAssembly portion of the code, you basically just go and invoke the API, sending it the information of the exception and letting your server side or your server project um, doing all of the logic for storing the exception in the table, but then you will only need to have the settings in your server project, and they will never travel to the client side. Okay, so continuing with this, we have our instance of the custom logger, which implements an logger. We receive as a parameter the log level, the custom logger configuration. We store those private variables. We are not using the begin scope, so we just return null. In this enable, we check if the log level for this logger is equal to the log level of the that we receive as parameter. All of these methods are actually being invoked automatically by the dependency injection when we register the provider and the login. So we also have a new class which is going to be log data that inherits table entity, and table entity comes from the Microsoft.Azure.cosmos.table package, and this is what allows us to insert in an Azure table. Okay, these are the properties we are going to store in the table. And then you will see that here we also have the log method. This is the one where we have all of our logic to insert the data in the Azure storage table. We are just printing a console.writeline with some text, so we see the message in the console. And by using a task.run, we are invoking, or we are having there the code to store in our table. So we basically get a cloud table client by sending the Azure storage URL, the Azure storage key, and well, the credentials, which needs the Azure storage key and the account name. We create a new instance of log data and we send the values. Then we need to get the reference for the table reference, which is named get exceptions log. We have one already created in Azure storage. And then we do an insert operation, table operation, insert and merge log data. So we create a table operation variable, and then we execute that operation. Now you will see that here we have our exception log table, and if we run the application and we do a search, I already went to the code and manually force it to throw an exception, so we see the values registered in here. So you see these are all of the exceptions that were registered, and here we have the actual created time with timestamp, the exception is string, and the message. The method or operation is not implemented, and that's because I had already gone to the search.razor and I force the code to throw an exception when you hit the search button. In order to register the provider, you need to go to the program.cs and in program.cs you will basically do builder.services.add login. We implement the configure method or the configuration, and we get an instance from custom logger configuration by getting the section with the same name and casting it or getting it as custom logger configuration type. And then we do configure to this variable that we have uh, as a parameter for the add login. And the we do configure add provider, I'm sorry, and we send a new instance of custom logger provider to which we send the custom logger configuration that we retrieve from the application configuration. And that basically is what makes our WebAssembly portion of the code to support the global exception handling. So any error that happens, the way we have it implemented right now, we are going to have that stored in an Azure table. And then you can consume that from Power BI reports, or you can go to Azure and see the Storage Explorer and see the errors that are registered in there. I hope this video has been useful. Let us know in the comments things you would like to learn about .NET Core, Azure, and Unity 3D, and I'll see you in the next video. Thank you very much and have a great day.